Okay, so let's get started. I'm Yiming Chen from Origin Lab Technical Support Team, and welcome everyone to today's public webinar. And in today's webinar, I'm going to cover some of the features of curve fitting in Origin. So during the webinar, just feel free to put your questions in the Q&A window, and I will keep an eye on it and will help to answer. And the recording of this webinar will be put to our website early next week. Okay. So before going through each topics, I will just mention some of the useful web pages. So first of all is our product page on the website for curve fitting. Yeah, let me just quickly show you. So on this page, you will see the different curve fitting features that Origin supports, and you can just go through them. Don't forget that Origin also supports apps. That's a good extension for the feature of Origin, that you can download the apps which are related to curve fitting. Okay. Also remember, we have two different versions of Origin: standard Origin and the OriginPro version. And if you go to this web page, you will see most of the curve fitting tools are available for both Origin and OriginPro. And you can just notice that like the fitting comparison feature is only available for OriginPro. Yeah. And in today's webinar, I will just cover like the general usage of curve fitting. But if you go to the curve fitting tutorial page, there are a lot more interesting topics and more like advanced usage of curve fitting. Okay. For example, you can come here to check how to define a customized fitting function. It has very detailed documentation here. Okay. Yeah. So let's get started. First of all, I will show you the gadgets of curve fitting. So gadgets is like a small tool that's applied on the graph. Okay. So you will see the gadgets menu only available when a graph is activated. So let's start with the linear fit gadget. So here I have this scatter plot where maybe there are two sections of data. And let's go to the gadgets, and I will choose quick fit and the linear. So the gadgets will put a region of interest box on top of the plot, and you can resize or remove the ROI box to cover the area that are interested. And if I double click on this yellow area, it will open this preference dialog, where you can customize the labels on top of the boxes and the report sheet and also the report box on the graph. So if I go to the ROI box tab, and you can choose which parameters to be shown on top of the box. Right now it shows the intercept, slope, and x-intercept. You can, if I just uncheck that and click apply, and you'll see nothing shows there. And you can show the R-squared values, Pearson's R, things like that. And you can also show customized label. Okay, let me just close this first. So it involves some advanced syntax. Let me see. Okay. If I go back to the customer label and put the syntax here, basically it will show the reduced chi-square and the slope, and with 4 decimal digits. So this is the format syntax, and the 3 decimal digits for slope. And if I click apply, and you will see the custom label show on the top. Okay, and when I output the result, I can choose where to output the report, where to output the result. So by default, it outputs to a result log. I can change that to a worksheet. Okay, so when the results are in the worksheet, you can do further analysis with the data. And here you can pick which result to be output. So I will just keep it as it is. And for the label box, this will, so when I output a result, it will also put a result box on the top of the graph. So here I can just choose the interested item. So for equation here, I will show the equation with values. Okay, and for the parameter table, let's use the ROI box tab settings. So I wanted this label to be shown in the report. Okay, and the rest maybe you just uncheck those. One thing I think is interesting is the range of the x, because maybe index. Okay, so I'm checking the curve fitting for 2 sections of data. Okay, let's click apply. Nothing happened here because you need to click this triangle button and say new output. Okay, let's click this. Okay, and you see a result is shown in this box. The range of data, the equation weighting, and also the statistics. Okay, and also the result is also output to a workbook. Okay, it has more detailed result here. I can move the ROI box to another region, and yeah, let me make it smaller, and say output again, new output. So it will append the new output to the existing worksheet, and you see it's of different X range data. Okay, and it generates a new result box, and I can move it here. Okay, even if I close the gadget, the fitted curve is still shown on the graph. So this is the one gadgets that's for linear curve fitting. Okay, let me see. Some people is asking question. Could you show an example of fitting with yeah, so because this is a general, yeah, I will show the example of doing simple fit. I will show you how you can put a fitting function there. Yeah, you said someone has 2023 and don't have gadgets. You have to activate a graph first in order to see the gadgets menu. Okay, if you activate a worksheet, it doesn't show there because the menu is sensitive to the graph, to the window that you activated. Okay. Let's go to another example of curve fitting gadgets. So in this example, I have 3 curves on top of the graph. So if I use the gadgets, let's say I still choose the linear quick fit, the gadget will be applied on one data set, and you can see the fitted curve. Okay, and you can click the triangle button and say I want to change data. I want to see that gadgets be applied to another data set. Okay, and you can read the values on the fitted values here, and I can even change the fitting function. Right now, I'm just use the linear fitting function. I can, let's say, change function to exponential decay. Okay, so this is more like a exponential decay data. I can resize the ROI to cover the entire range of the data. Okay, and I can just click this button and say I want to output for all curves on the graph. Okay, yeah, if I just click that, oh, it just do the curve fitting on all the data set. Yeah, because I didn't make any changes to the setting, it just output everything. Let me quickly change that. So if I double click on the ROI and I want to output the results of worksheet, okay, and I don't want the label box to show on the graph. Okay, let's try it again. So this time, if I say new output for all curves, so the result will be appended to a worksheet. Okay, and yeah, you can see the data set name and the fitting result in the table. Okay. 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 So let's go to the next example, simple fit app. So in this example, I'll show you how you can put your own fitting function. Okay. So first, I will show you the a simple fitted app. So it's called a simple fit. To download the app, you can just go to the apps panel and click the add apps. Okay. And here you can do some searching like curve fitting. And you can find all the apps related to curve fitting. And you will see this download button. And if you click it, it will download and the app icon will be shown in the apps panel. Okay. Oh, so some of the app needs administrator privilege to install. But yeah, just to let you know that. Okay, so here I want to fit this data set with the Gaussian fitting function. Let me just copy the definition of the function. Okay, then this time I will use this simple fit. So this app is only applied to a graph. Okay, so you need to first to plot out the data and then choose this app. Okay, so in this app you can fit with a linear function, polynomial, or nonlinear. Okay, and here you can enter your fitting function. Enter the fitting function here. Origin will automatically recognize the fitting parameters in this function. Okay, so A, B, and C, but by default it just put 1 as the initial parameter values. Just so you know that in order for the fitting to be successful, the initial value is very important. So if you define your own fitting function, you need to type in the initial guess of the parameters. So if we roughly check the plot, so A is like the amplitude, so I can just put 80 here, so the amplitude of the peak, and B is like the center of the peak, so it's roughly at 25, and the C is like the width, so maybe 10. Okay, don't have to be very precise, just put in some values that's close to the final fitting result. Okay, I can show the confidence band on top of the curve, and if I click one iteration, you will see it says the chi-square reduced. So it just reduced the chi-square to find the fitting parameters. And you can also say fit. It will fit until converge. Okay. So this is an example that you can put it in your own fitting function. Okay. You can also use the origin existing fitting function. So if you check this box, and it will use the existing fitting function, and you can pick a fitting function category. Origin has more than 20 categories of fitting functions. So let's say I want to fit it with the peak functions, and you can also find the Gaussian or Gaussian amp. Let's say Gaussian amp as a fitting function. Then you will see that what is nice to use the system fitting function that the function has some algorithm to initialize the fitting parameters. So you don't have to manually put in the fitting parameter values. Okay, and these values are already very close to the final result, and it guarantees that the fitting will be converging if you just click the fit and it says fit converged, which is good. Okay, then if I click report, it will generate the report sheet in a side of this data sheet. Yeah, some interesting result are like the fitting parameters, standard error, and you can read the p-value to tell whether its parameters are significantly different from 0. Okay, and the R square is quite close to 1, which means the fitting is quite good. Okay, and also ANOVA table. Yeah. So this is for simple fit app. Okay. Let me see. Okay, yeah. My colleague Snow is helping to answer your questions. Okay, great. Let's go to the linear fit topic. So let's try a linear fit on this data set. Okay. The data set is simple, but I will show you some tips that you might miss when you use Origin. Okay, so if I go to the analysis and fitting and go to linear fit, let me open the dialog. Okay, so here there are multiple tabs with different settings. Okay, a lot of settings. And first thing I'm going to do is I want to go to the, I think it's quantities. Okay, so in order for the fitting to be good, maybe the data itself has some outliers. Okay, so I wanted this tool to detect the outliers for me. So it's under the quantities tab. There's this outliers checkbox. Yeah, let me check that. And there are other settings like which parameters you want to show in the report sheet, and what the statistics you wanted to see. Okay, yeah, I would just leave it as it is. And there are other settings like whether you want to fix the intercept or the slope at a certain value. Okay, and if there are different residue calculation methods. Okay, and one thing I want to mention is sometimes people want to define the fitted curve range. So we have a lot of settings for the fitted curve. For example, if you wanted the fitted curve to be spanned to the entire x-axis range, you can go to the x data type here. I think it's on the range here. You can say span to full x-axis range. There are quite a lot of settings. Yeah, you can play around with that. Okay, and you can define your own x range of the fitted curve as well. Okay, let's just click OK. And it says, do you want to switch to the report sheet? I will say yes. Okay, then it will just jump to the report sheet of this fitting. Yeah, still we can read the fitting parameters. So here it says that the p-value is above 0.05, so the intercept is not very significant from 0. So maybe we can adjust the model to fix the intercept at 0. Okay, and also the R-square value is quite low. So yeah, probably because of the outlier here. So if I expand the outliers node, it says the row number 6, the 6th point is the outlier one. Yeah, so it for sure this data point is the outlier. I can neglect this data point or cancel this data point. So in order for the fitting to be improved. Okay, so if I go to the left-hand side, I will choose this mask points on active plot. Okay, when I mask a data point, the data point will be excluded from the analysis. Okay, you will see let me go check the pointer, and you see this lock change color to yellow, which means the original data of this analysis has been changed. So the calculation needs to be recalculated. Okay, so let's just update the calculation. Now the linear fit is applied on the data without this outlier. And yeah, we can tell that the R-square value has been improved. Okay, now it's 0.1. It's very close to 1, which is good. And next thing is if I wanted to fix the intercept to 0, so I wanted to make some changes to the settings of this analysis, I can click the green lock and say change parameters. Then if I go to the fit control and say fix intercept at 0, okay, so I just change the settings of the analysis. And I can also, yeah, let me just check the find x and y tab. So I can use this linear fitted line for prediction. Okay, let's say find y from x. Okay, and click OK. Yeah, first thing we notice is that now the intercept is fixed at 0, so there's no error now. And then there's another sheet is generated. So here you can put your own x value, and it will calculate the y value based on the fitted model. Okay. Yeah. So yeah, you can use this sheet for prediction purpose. Okay. Yeah, this is pretty much the linear fit. Okay. Let me go to the nonlinear curve fit. So here I have, yeah, we have seen this data before. So I have 3 exponential decay curve and I want to fit them. This time I will use this fitting nonlinear curve fit tool. Okay, let me open the dialog. Okay. Yeah, so there's a lot of settings in this dialog. I will explain some of them. So first of all is under the settings tab, the function selection, you will need to specify a fitting function. And as I said, Origin has more than 20 categories. And in this case, I will use exponential decay function. So let's choose the exponential. And for function, even for exponential categories, there are a lot of functions here. And let's say I will just pick exponential k1. Okay. In the lower panel here, you can click the formula, and you know what the formula of this fitting function is, and you can also check the simulated fitted curve, of the fitting function. Okay. Okay. Then we need to specify the data. By default, the fitting will be applied on the from the active data plot on the graph. If you want to fit the 3 curves at a time, you need to go to the input data here, and to the right hand side, click the triangle button and say I want to add all plots in active page or layer. It doesn't matter because they are in the plots are all in same layer. Okay. Now you see 3 fitted curves are added to the plot. Okay. Then you can go to the parameters tab, and you can check the initial guess of the parameters. Okay. One thing is there are some buttons in the middle. Okay. One thing you can do is if I go to the message tab, and here you can click this button to calculate the chi-square value. Okay. And the button to the right is the 1 iteration. So if you click that, it will start to fitting, and you will see from the message that the chi-square is reduced. Okay. And you can also click fit until converged. Okay. If you want to fit all 3 curves all at once, you can click this drop down and say all. Okay. Then you can click the fit until converged. So this way it will fit all 3 curves at once. Okay. Yeah, there's some other settings like you can also, there are settings of the fitted curve like the linear fitting tool I showed you, and it also can do prediction, find XY, and I'm not going to show advanced settings today. And for the code tab, there are also some advanced settings like you can define your own parameter initialize algorithm here, and you can also put constraints of the parameters. So just keep in mind that you can only apply linear constraints for the parameters, and you can read the hint in the bottom panel how to do that. Okay, there are other advanced settings, and for the parameters I have just showed you, you can also apply the bounds for individual parameters here. Okay. So if you are satisfied with the fitting, and it is because it's converged, and you can click OK to generate the report sheet, and click yes to go to the report sheet. Yeah. So just make sure the fitting is successful. Okay. Let me move to next topic, replicate fit. So here I have this data. It's like a couple of like replicate measurements. So for those, I made 3 measurements, and so then I get a response 1, 2, 3, and I plot them out into one graph. I want to fit the entire data set instead of they are split into 3 data sets, but I want to treat them as one data set for the fitting. Okay, so again, let me just go to the analysis and fitting. You can choose the nonlinear fit last used here, to open the dialog directly. Okay, so in this case, I will use those response fitting function. So it's under the growth sigmoidal. And for the function, I will select those response. Okay. So again, by default, it will be applied to one data set. So I first go to the data set and select all three data sets. Remember, I click this button and it says add all plots in the active layer. Okay, so here for the multiple data sets fit mode, I have several options. So in this case, I want to concatenate all three data sets into one. Okay, so I will choose the concatenate fit. And in the preview fit curve below, you'll see they are just treated all the data set as one data set and fit a curve onto it. Another thing I want to show that you can adjust the fitted curve. Okay, instead of just showing a curve, I can show the if you go to the plot type drop down, and I can say I want to show as a mean and a standard deviation. So if I choose this, then it will calculate the mean value and standard deviation of each row of the worksheet and show on the graph. Okay, and so for the fitted curve, instead of showing, I can show the fitted curve plus mean standard deviation. Okay, so the rest are the same. So the fitting parameters are already initialized properly. I can just click the fit until converge and then click OK. Do you want to switch to the report? I will stay with the graph, so I click no. Yeah, and this way, you see the fitted curve as long as the mean and standard deviation of the measurement at each dose value. If you go to the object manager, if you just hide the data point, and you can just check the mean standard deviation as well as the fitted curve. Okay. So this is for replicate fit. Okay. Next, I'll show global fitting. So let's just first pop up this graph. So this is an embedded graph. You can double click to pop it up. First of all, let me duplicate. I click this duplicate button to make a duplication of the window. Okay. So first, let me just perform a Gaussian fit on one data set. Okay, I'll just show you this tip fitting and nonlinear curve fit. Open dialog. Yeah, I know the Gaussian function is also under the basic functions category, so it's Gaussian amp. Yeah, I would just leave the other settings as it is and say I want to just click fit. No, I will stick with the graph. So now I have a fit one data set. So here's a tip that you can apply the fitting to all other data sets. So you can click the green lock here and go all the way down. Say I want to repeat this for all plots. Okay. Then it will just duplicate this curve fitting on all other data sets on the graph. Okay. Yeah, just a small tip here. Okay. Next example I will show is global fitting. So maybe there's sometimes that there are assumptions that maybe the width of all four curves are the same, and you want to share the width parameter among all data sets during the fitting. So here we have this global fitting option. Again, let me just go to the nonlinear curve fit. And okay, Gaussian amp, which is selected. And for data selection, I would again include all data set. So this time I need to say all plots in active page because they are from different layers, right? Okay. Let's so for the fitting, I will choose all. So I will fit all the curve all together. Then we will check the multi-data fit mode. This time, instead of fit them individually, I will say global fit. Okay. When I choose global fit, then I switch to the parameters tab. You will see there is an extra column here called share. So which means I can share the width of all data sets. So I just click this box. Okay. Then the width is parameters shared among all data sets. Okay. And leave others as it is and click fit until converge. Okay. Yeah, then just click down to check the result. Yeah, this time I will just switch to the report sheet, and you can see already the fit curve is being added to the graph. And you can check the width value of each curve has been are shared, right? And it also has this star mark on it. Okay. Yeah. So this is an example that you can share parameters among the data sets. Okay. Next example is specifying X range. So you can just fit a part of the data set. So for example, if I want to only fit the third peak on the graph, and I can first to select the region. Okay, I can use this selection on active plot toolbar. Let me just click that. Okay, then I just drag a region on top of the curve. Yeah, I can also move the bounds a little bit and double click it to confirm. And yeah, just let you know that if you click on this bound, there's a mini toolbar will show up, and you can you can select a part of data and delete them. You can copy the data of the selected data, or you can just hide the data outside of the region. Okay, yeah, just some let you know you have this option. Okay, and reset to full range. Okay, yeah. Then if I run the curve fitting on the curve, let's say analysis, yeah, I can just go to the last used. Sorry, this dialog is too big. Yeah, if we look at the graph, you see this curve fitting is only applied to the region that I selected, right? Okay. And I can say, if I use a Gaussian amp and click fit until converge, you can tell the fitting is not very well, especially at the side of the shoulder of the peak. So we can switch to a Lorentzian. Okay. Yeah, this is much better. Okay. And click OK. So this way you just do a curve fitting on the selected data region. Click No. Okay. Yeah, you can even customize the fitted curve with the mini toolbar. Okay. Yeah, just want to show you that. Okay. If you want to fit all three peaks all together, yeah, we have another webinar called peak fitting. So we can use a peak fitting tool, but if you can also use the nonlinear curve fit tool. Okay. Yeah, just to let you know that you have options. You can use this nonlinear curve fitting to fit multiple peaks as long as the background or the baseline of the spectrum is not complicated. You don't have to to subtract the user-defined baseline. Then you can use this tool. instead of just using one peak, you can go to the advanced. Okay, so here find this node called a replica. Okay, you can replicate the peak. So by default, it's just one peak. I can say I want a 2 extra peak function. Okay, yeah, you see, it will just fit the spectrum with another 2 peak functions. Okay, let me just change that. Okay, it's already Lorentzian, and fit until converge, and click OK. Yeah. So just so you know that when you are fitting the curve with a peak function, you can duplicate the peak in the fitting dialog. Okay. Oh, let's go to next topic, fitting with Y areas. Okay, sometimes when you do a measurements, the result from the instrument, it may also come with some uncertainty of each measurement. So here I have an extra column, which is the error column, which defines maybe the uncertainty of the measured value of column B. Okay, I want to involve also include the error term in the fitting. Maybe for the large areas, I can apply less weight to that data point. So that's the idea. To do that, we can yeah. So here is the plot. I can also run the nonlinear curve fitting with the error term. Okay, so nonlinear curve fit. Let me just use a Gaussian. It's strange white. Okay, let me for data selection. Let's just reset. Let's try reset. Add our plots in. Just add this one. Okay. Still, it's strange. Let's start from the worksheet. Okay. Okay, use the Gaussian amplitude. Okay. So we can go to the data selection and expand the input data node. We want to make sure the error term is involved in the fitting. Okay, so expand the Y value, and see the weight here is instrumental. So there are other weight settings that you can use, but in most of the time, I guarantee that in 90% you will use the instrumental as the error. Okay. Then for the error values, we are using the column C, which is the error. Yeah. Okay. Just to make sure that the error term is involved in this fitting. Okay. And click fit until converge. And click OK. Okay. Next, I will also talk a little about the curve fitting apps. I will cover 3 apps here, the fitting function library, the first one. Other than the system fitting functions, Origin also have other fitting functions that you can choose from. You can download this fitting function library app. If you click that, yeah, these fitting functions are all suggested by our customers. Okay, and if you want to add this fitting function to the to Origin library, you can let's say just select the fitting function. Okay, just select one and say download, and you see this mark means it's being downloaded. Okay, then let's say what the name. That's a solar cells amp W. Okay, fitting organizer. Let's say no. Then if you go to the fitting function, nonlinear curve fit tool, it should be added to the user-defined category. Okay. Yeah, sort of cells. Then, yeah. So yeah, this way you can add the fitting function from the fitting function library. If you have any fitting function that in your mind you want Origin to support and you could not find in our library, you can request a function, and yeah, you click that, you will open our technical support page, and you can send us a suggestion. Okay, this is the fitting function library. Next, I will show a speed fit app. Here I have a lot of data sets. If you already know that, you can click view and column list view to check the data sets. So it has like 96 data sets. Okay, and I want to fit them all. Let's go back. So here we have this speedy fit app. Yeah, let me show you. So use this tool. Yeah, again, you can select from a linear fitting function, polynomial, nonlinear curve fit. Yeah, let me just use the linear. And you can click the button to check the fitting result of other data sets. Okay. And you can also click the drop down to choose which data set you want to check. Okay. And for the report settings, let me just, yeah, you can pick which parameters or the statistics to show in the report sheet. Yeah, I just want to uncheck the last one. So I don't want to show all fit the data and the curves. It may make it slow. Okay. Yeah, let me click OK. Yeah, it will run the fitting for all the data sets. And again, here you can click the button to show the results one by one. And you can also let it automatically navigate each data set. Okay. And there is a summary result sheet being generated here. Okay, so on the left hand, the first column shows the data set name, and you can check the maybe the most interesting one is the R square values, and this way you can quickly tell which data set is not being fitted properly. And okay, if you know how to use the worksheet conditional formatting, okay, let's say I want to highlight the cells with values below 0.8, for example. Let's say grade less than 0.8. Yeah, I just want to highlight the cells with low R square values. Okay. Yeah, this way you can quickly check the which one the fitting failed. Okay. Okay. So the last app I want to show is the rank model. So here I fit the data set with two exponential decay function. So one is with one exponential decay term, and the other one with a two exponential decay term. And if you just looking at the R square values, yeah, for sure, if you add more parameters, that will improve the R squared. But the question is whether the extra exponential term is justified in this fitting. And Origin has this app called the rank model that you can compare multiple models and use AIC, BIC statistics to tell which one is overfitting or underfitting, because those two statistics all involve the punishment of the extra parameters. So it's a rank model. Okay, let me start with the data set. Rank models. So here you can first pick a category. Let's say I want to compare the fitting functions on the exponential category. Yeah, I can just 1, 2, 3 exponential decay function. People may ask whether they can, to compare functions from different categories. Yeah, the answer is yes. So you see this plus button here. If you click that, you can generate your own categories and put the functions to the category that you can choose from. Okay, yeah, just to let you know. And then which stats you want to see? Maybe I just reduce. Okay, so let's just check the reduce sum of squared. Okay, then if I click apply, the data will be fitted by the 3 models. Okay, and you will see in the result table here, it's already sort the AIC values by ascending order. So the lowest AIC is obtained by the exponent decay 2 function. So which is the optimal fitting functions in this case. Okay, and yeah, if you check the BIC, the lowest value is also come from the exponential decay 2. And if you read the residual sum squares, I think even if you fit with 3 terms, it's not improved much, a lot. So definitely we'll pick the fitting function with the less exponential terms. Okay. Yeah, if you just click different row, and you can check the fitting result of different functions. Okay. Let me click output or. Okay. Close. Yeah, you can check the results. Okay. Okay. I think that's pretty much today's webinar. I will leave this screen open for a while, and if you have more questions, please let us know. Yeah, let me just quickly read.